Hello and welcome to Project Management for Researchers, and this is part 2, Scheduling. So this is a series that was originally developed as a set of workshops for the EDGE co-fund program, which was a cohort of postdoctoral researchers. So this does work best as a classroom where we can exchange experience and ideas and go through a lot of questions and answers. What you have here today is a recording of a shorter version of the session where I'm just going to go through the key points. But if you do want to do the classroom, if you do want to do the workshop, do get in touch. My name is Richard Tuig. I'm a program manager at Trinity College Dublin. So in part 1, we covered budgeting and financial aspects of projects. In part 2, we're going to look at scheduling. Always remembering that the tools and the processes and the things that I'm going to go through are derived from the project management body of knowledge, which is a manual for how to run a certain kind of project. And generally that's a project that has a fixed start and a fixed end, but a very well-defined scope. And normally the budget can vary, so I can come in under budget or over budget. And actually I can come in ahead of schedule or behind schedule, as long as I deliver the scope. Research projects are a little bit different. Generally the scope is very fuzzy, but I have a ceiling to my budget and I have a fixed end date, and I'm trying to do as much as I can within that period. So we have to remember that difference between kind of standard projects that the PMBOK considers and our research projects, and adapt our tools as we go to suit the kind of projects that we're running as researchers. So today is about scheduling, and a big chunk of scheduling is estimating, because any project can be estimated accurately, say here, but only at the end of it. So there's always going to be an inherent error and inherent risk in our schedule, but what we want to do is understand what that risk is and account for it when we're doing our planning and our proposal writing, and our later phases of planning. So we have our proposal writing stage where we plan, and then we have our planning phase, which is either just before our project or as the project kicks off. So that's what we're going to talk about. Number 1, setting up the project plan, maybe a proposal stage, or maybe later on where we revisit our plan just as we're starting our project. Most researchers, when we think about scheduling, would go straight to the Gantt chart. So this is a Gantt chart. It was developed by Mr. Gantt. He wasn't the first person to write a list of tasks and draw out lines on a piece of paper to indicate when they should be done, but he was the first person to kind of formalize it and set up a way of doing it that would be followed by everyone after him. But what is a Gantt chart? It's a communication tool, and it's a way of communicating a plan, or it's a way of communicating progress against a plan. So therefore it's a picture essentially that we may put in a proposal or we may put in a report. What's really important though is the information that goes into the Gantt chart. So I want to focus on getting that information right and understanding the limitations and the errors inherent in developing a schedule that produces a Gantt chart. I'm not here to tell you how to draw a Gantt chart. You can draw a Gantt chart however you like. A slightly more complex manual for project planning and scheduling is the Program Evaluation and Review Technique. This is a US military handbook, and it includes a whole load of chapters on different things that they collected together for the Polaris missile development project, and they defined all these as the best way of planning and then monitoring project progress. What's PERT include? It includes a thing called the work breakdown structure, which I'm going to cover. It includes network diagrams, so ways of drawing out task relationships and project structure on a piece of paper, and that includes Gantt charts. Gantt chart is a version of a network diagram. And something that they stole from DuPont, which was called critical path analysis, which we're going to cover, and that's a way of looking at network diagrams and looking for key relationships within them. And then a whole chapter on probability and statistics around duration estimating, and we're going to talk about that in this session. So what are the challenges in research? These are the kinds of comments I get when I start talking about planning and drawing schedules and making decent plans is, oh, well, I don't really know what I'm going to do. Everything's quite poorly defined. Everything's a bit fuzzy. I'm not very confident in my duration estimates, so it doesn't really matter the plan that I draw now because I'm going to change things anyway, and I know they're going to change. I know my end date is fixed, but I have a variable scope, of course. It's a research project. And this feeling that even if I draw things out sequentially and I draw out a nice sequential Gantt chart, I just have to start everything anyway because I need to do things safely. So therefore, I need to do everything at the same time. These are real challenges, and I'm not saying these don't exist. What I want to do is show you that by doing planning and scheduling properly and understanding the limitations of it, it helps us overcome these challenges and it helps us address them. So some of the tools. Number one is the work breakdown structure. In PERT and in the original standard project management definition, this should be a deliverable orientated decomposition of work. So that means each level of it only lists a deliverable. It doesn't say how that deliverable is done. It says what the key deliverable is at the end of that task. It organizes the whole of the project. So it has 100% of the project in it. It covers everything that is in it. And it breaks down that entire scope into a sensible level of decomposition where we can address it in units. So the example they normally give is a construction project. So if you look at something like a house, you can see at the task level, they don't list how the walls or how the foundations are to be built. They just list what the deliverables are: foundations, walls, ceilings, roof. No instructions as to how they should be achieved. This is different from how we do it in research. We don't have a well-defined scope and a well-defined set of deliverables beneath it. What we have is a problem. So our top level is going to be a problem, and our tasks are generally going to be approaches. If we can put a deliverable on them, then great. But if we're just going to list the approach that we're going to try in that task, then that is acceptable for a research project work breakdown structure. Right now, I'm going to address the question of deliverables versus milestones because it always comes up at this stage of the workshop. So what is a deliverable and what is a milestone, and what is the difference? A deliverable is something that is tangible that you can think about actually handing over. So something like a data set or a report or a drawing, you can always imagine printing that out, making a physical copy of it and giving it to your sponsor and handing it over. So it's something really, really tangible. It may have a due date, but you'd still hand it over as soon as it's complete. So it could happen before or after that due date. As soon as it's done, it's packaged up, I'm going to hand it over. And it's defined as a target output of the project. A milestone is a different thing. A milestone is a moment in time, and it's a tool that is used to address project progress or performance. So you set a date for that milestone, and you'd mark it complete when it's passed. So the difference between the target date and the mark completion date would tell you how you're doing in progressing your project. But it's an instantaneous thing, so it may be an approval for something. It may be that a package of work such as procurement has been completed, or maybe a specification that is finalized. A milestone, a deliverable can be considered a milestone if it's something that you want to call out in your plan as something that is critical to measuring the progress of the project, that deliverable being complete, then you can call it a milestone. A milestone is never going to be a deliverable, so you're never going to hand over a milestone. You can't hand over a moment in time. I hope that makes it clear the difference between the two. Deliverables you do first at the planning stage. Milestones will come later when you're looking at how to track progress during your project. So I've got an example project here, and I've tried to make it as research appropriate as I can, which is difficult for me because I'm more of a product development person. So it sounds like a product delivery project. So I apologize for that. But I'm going to set it up as a problem. So it's a problem where I have a cafe that needs something novel. It needs a new menu, and it has a target date that has to be ready in 18 months. And then I'm going to break that down into objectives. And my first objective is going to be the egg component of that breakfast. And I've set a kind of satisfaction rating, so I'm able to validate whether that concept has been complete. So I've got an 80% approval rating. other objectives will go down there. And because of this 100% rule, I want to include everything in my work breakdown structure that is in the project. So I'm going to include promotion activities, and I'm going to include project management activities in there as lower objectives. So I'm going to break that down into deliverables. So the deliverables that I want to have out of this, I'm just thinking about my egg objectives, are a public report on global egg trends. So I'm going to look at everything that's out there. I want that recipe for the new egg component, the novel part of my project. And I want some kind of validation deliverable, which is going to be my tasting group report. Just going to think about deliverables for now. Remember, I said milestones is going to come later when I look at tracking. So I'm going to sketch out a network diagram for my project. So there's a review for global egg trends. That is a deliverable, but it's also, I can describe it as a task. Here is an approach. So this is a component of my work breakdown structure, but as this is a research project, it's not a deliverable based component. This is an approach based component. So I'm going to do a design thinking exercise to come up with my next deliverable, which is my selected recipe. Work backwards, I know that then therefore I have to do some work around setting up my teams. So I need my design thinking team, I need my validation team. And then I was looking at this thinking, okay, well, I could get something out of the project a bit earlier on here. If I've got this review of global egg trends, maybe I can publish that and make it into a recipe book. Okay, so it's a simple project. I'm just using this as an exercise. I'm going to list those things as tasks at the lower level than my top level work package in my work breakdown structure. I've also put down some subtasks here, but I've decided that I'm not going to spend too much effort on thinking about the subtask level. So I'm going to make a conscious decision that I'm only going to really think about relationships at the task level, so the 1.1 level, 1.2 level of my work breakdown structure, and I'm only going to think about those durations. I don't need to go into the detail for the subtasks. It's not going to add any value to my planning to put relationships and durations around the subtasks. So I could draw a Gantt now based on this information. What I want to do is think about where are the important relationships in this. So I'm going to do a bit of critical path analysis within it. And in order to do that, it's best not to do it as a Gantt chart. It's best to do it as a network diagram, because then I can use one of these standard nodes where I list all the start dates and finish dates around my task itself. And it's a nice way of looking at it. So sketch out my network diagram as a node diagram. The first thing to do is put in those durations. So I put my tasks in the middle box, and I put my durations of each task in the top box at the middle. I then run through a forward pass where I work out the earliest start and the earliest finish based on those tasks. And my convention is that tasks start on the first day and they finish on the last day, and then there's the next task after will start the day after. So you can see I'm filling in the top row the earliest starts and the earliest finishes of these tasks based on the durations that I have. You could write out a formula for that, but I think you're intelligent enough to see that I'm just adding the value and then I'm sort of subtracting 1 because I'm finishing on the finish day of the task. I could draw a Gantt chart based on this information, and it would be my forward pass Gantt chart where I've just listed the earliest starts and earliest finishes. The interesting thing to then do is the backward pass. So I start with the latest date that each task could finish, and I do the same exercise, but I work backwards. And I go through all the tasks and I look at the latest finish and the latest start based on the duration that I have. I can then work out the float, which is the difference between the earliest finish and the latest finish of each task. And you'll see that's the same as the difference between the earliest start and the latest start. Some tasks have a float of 0. That means they are on the critical path. And what that means is any delay to that task will delay the end date of this network. If it's not on the critical path, it can delay the end date, but only if it goes over, say, 3 days or 5 days, if you look at those tasks. So they have some float, some delay is allowed in those tasks, or is possible. So there's my critical path. What does that mean? If I want to avoid this project going into delays, I can't allow any of those tasks to have delays. If I want to speed up this project, I need to add resources or fast track by putting tasks in parallel on that path. So that's the path to concentrate on first if I want to speed things up. Right, so like I say, I can draw a Gantt chart, and this is a Gantt chart based on the forward pass numbers in that network diagram. It looks nice. I can do some fancy things. I can do critical path on, and I can draw the floats. Does this make it a clearer picture for my sponsor? Probably not. So I might include those on my own Gantt chart. But if I'm really trying to use this as a communication tool where I give an accurate picture of my project, I probably don't want all the bars and extra colors on it. So I might just leave them off for now if I'm putting this into a proposal. But at least I know. I can mark my deliverables on. So there they are. Sorry, I'll go back. They are review global egg trends. There's my egg component, and there's my tasting group report. But actually, when I'm doing my Gantt chart, I'm going to think again about whether they're all necessary, because I don't want to have too many deliverables. So I've decided just to have that tasting report and that output of the recipe book. And I can draw them on. What about milestones? A milestone is used to track progress. So I want to define as many as necessary or no more. The convention is that these are labeled 10, 20, 30, so that's just a way that things are done on Gantt charts. I'm going to say that the decision point for my egg component is a milestone, and also that deliverable of the egg recipe book, I think that's a valuable output. So I'm going to have that as a milestone as well, because then I can track those as a metric for my project, and I can mark those on my Gantt chart. So that's a nice way of communicating my plan to my sponsor. I can do some really complex things with Gantt charts, particularly in Microsoft projects or like other kinds of project software, where I do things like resource leveling. Here you can see an example where I've put how much effort each task takes. So then I can set a maximum effort, and I can level this, so I have to move tasks around in order to allow them to be done based on the amount of resources that I have available. However, normally in doing that, I have to break some constraints. So you can see here that the publication task, I've had to split that, and I've had to allow it to start before the finish date that it was previously linked to. So I've had to prioritize my resource constraints over the task relationships that I already had set. So you generally do this as an iterative way, and it is quite complex. You really want to do this using software if you can. Right, so you have a Gantt. What do you do with that? Here I'm going to talk a lot about duration estimating. And this is to understand how accurate my Gantt is and whether I've drawn it in a sensible way. Things to be aware of. Anyone requesting work tends to be overconfident in their estimates. So they tend to assume there's no risk in the schedule. So that could be the PI talking to the postdoc, it could be the sponsor talking to the PI, it's the person who's asking for the estimate. The people executing the work tend to put in time to protect themselves. Sometimes that's called padding, where you just add a little bit of time to make it safe that you can do it. Sandbagging is more of a, let's say, negative term, where I purposely make my duration estimates ridiculous in order so that I could say I set a duration of a year for a task that I know is going to finish in a month, just so I can look very good when I achieve it really early on. So a few more military terms around this. A lot of this duration estimating and project planning comes from the military. These are Vietnamese ones, Vietnam War terms. They said they tend to refer to duration estimates as a WAG, so a wild ass guess, and that would be as opposed to a SWAG, which would be a scientific wild ass guess. So a guess, a WAG is a guess that you just come up with no basis. A scientific guess is one where you have some logic to it, and therefore it is more trusted. Methods for estimating. So to go from that WAG to the SWAG, you want to have some kind of scientific estimating method behind your estimate. You can use an analogy, so you can look at a project that happened last year and directly transfer the estimate from that project to this project. So it took 6 months last year. I'm going to give it 6 months again. slightly more complex would be to use some kind of parametric thing. So, okay, so it took 6 months last year. This time I know that it's going to take twice as long in terms of the work, but that only applies to the writing phase. So I'm going to scale everything, and I'm going to use some maths and come up with more of a scientific estimate in that way. That's a parametric estimate. Second way is to use some kind of forecasting technique. So again, this is a military one. It's called the Delphi technique. What you do is you set up a panel of experts. You make sure that they're geographically separate, so they're not talking to each other, and you ask each of them to make an estimate. So they're not aware of each other, and they're not aware of what each other are saying. You then summarize the results anonymously and share them between all the experts, and you ask them to do that estimate again. So it's an iterative process. You may do this 2 or 3 times. The advantage of this is, okay, you get a more accurate estimate, but you also get to say that you used a documented, widely accepted forecasting technique to do it. So if somebody says, how did you come up with that estimate? You say, well, I did it by the Delphi technique. Iterate until you get a consensus. Once you have your estimate, how do you work out how much you trust it? And this is where the probability tools in PERT come in. And this is the really interesting stuff. So the setup is, when you get your estimate, you always ask for 3 estimates. You ask for an optimistic estimate. So you ask for a best guess estimate. So that is your best idea of how long this task is going to take. You also ask for an optimistic estimate. That is, if everything goes perfectly and everything is really smooth, how long will it take? And then the pessimistic estimate is, say everything goes wrong, but you still accomplish the task. How long could it take? So you have 3 estimates. You then calculate an expected value using either a triangular or a beta distribution. The choice of triangular or beta depends on how much confidence you have in those estimates as to whether this task has been done before, so how much prior knowledge they have. Generally use a beta distribution unless you have a reason to use a triangular one. So going back to my example, so if I'm going to do this at the top level. You only do this on a sequential project, so you'd only do this on a critical path. So you have a series of tasks that feed in one by one into each other. So I'm going to do this at my work package level, where I know things are happening one by one. I have my 3 estimates for each work package. I have an optimistic estimate in terms of months, best guess, and a pessimistic estimate. And I may have got those by my own historical data, a parametric estimate, or I may have got those by a Delphi technique. I then calculate my expected value, and I'm going to use a beta distribution. And straight away, I can see that my expected duration for the project is 17.7 months, whereas my best guess duration for the project was 17 months. So both of these are longer than, so my expected duration is longer than what I've already drawn on my Gantt chart. So, okay, I know I have a bit of a problem, but how much of a problem do I have? And that's the power of the PERT analysis. So I calculate my variation, my variance, and I calculate my standard deviation. I'm not going to go into the statistics of this. This is kind of senior school level statistics. So you may remember normal distributions and the way this is done. What you do is you approximate to a normal distribution with your target finish as the x and the expected value as mu, and you have your variance, your standard deviation. And then you work out a z value and you look that up in tables, or you use Excel to give you a probability. So based on the example I gave on the page before, my probability of finish on time on this project is just under 40%. Now that's not great. And it's quite easy to show on a complex project. If you have 10 or so sequential tasks, you can easily get down to 3 or 4% probability of finishing on time based on the best guessed estimate. I can run through scenarios, and this is something I can do in Excel really easily. And I can say, if I want to have 80% probability of finishing, I can work out how much time I need to allow myself for the project. If I want to have 99% probability of finishing on time in this project, I need to allow myself 22.8 months. So I want to set myself an achievable timeline for the project. I don't want to set out on this project knowing that I have a 60% chance of failure, because that sounds terrible to me. I want to say that I'm going to be 99% chance of finishing on time. So therefore, I'm just going to redraw my Gantt chart and I'm going to scale everything out to that 23.8 months, so nearly 24 months. You might say, well, that's just padding. Well, it is just padding, but I've done it in a scientific way. And what I would generally do is I would keep that original Gantt chart for myself, and I would put this achievable Gantt chart in the proposal to my sponsor. And it may be that I have to negotiate an extra time. Remember that I said I wanted to achieve this project in 18 months. It's quite clear that I can't. I'm going to say I'm going to achieve it in just under 24 months. And if that is the case, maybe the sponsor will allow me to drop something from the project, because I know that if I include everything in this project, it would the probability of me finishing it on time is very low. Good. A few bits of general advice for research plans. Like I said there, your end date, the one you have in your best guess estimate, and the one you put in your proposal can be different. You don't have to give out all your estimates and all your personal plans to your sponsor. Proposal writing, we know, is an art, so you always have to include too much work for the term because you have to be ambitious to win the funding, and there's no incentive to finish early. This is something that takes practice to get right, to include the right amount of work, that you're showing ambition, but you're not putting yourself in a position where you have no chance of finishing the project. Always plan to fail, always plan to change. I'm going to talk about risk management more in scope management, so this is a whole topic in the next session. Do include interim milestones and key deliverables that are valuable by themselves. So even if you don't get to the end of the project as you planned it out, you've achieved something as a key deliverable by itself, at least halfway through the project, if not earlier. I want to talk about concurrent activity and sequential activity because this is something that always comes up. So why have I chosen to do everything one after the other in this project? Wouldn't it be better? Wouldn't it be safer, you may say, and it's kind of natural instinct to just do everything at once, because then at least I know that if one fails, I've got everything going and I can transfer all my resources to the other one. So a lot of people, even though they draw their plan like this, start off like this. The things to be aware of is multitasking isn't real. You can't actually do everything at the same time. And if you're working on a complex research project, that means you'll be switching from something quite complex to another thing quite complex all the time. The other thing is your exercise in tracking and putting milestones down in order to track progress is completely pointless if you started doing everything like this, and I'll show you. So multitasking is a myth. There's always a switching time between work, so you have to stop one thing, move to the other one, get your brain back in order, work out what you were doing, go back to that, and then again move back to the original thing again. So you always add a little bit of time every time you switch between work. So that switch time is going to impact the end date of your project. It's going to extend the time to do this project. All your milestones are going to be pushed to the end, so therefore it's very difficult to track progress, and it's really difficult to see if there's any issues that are delaying your project because everything is moved to the end. And then if the project stopped early, I haven't achieved anything because I've tried to do everything at once and therefore I've slowed everything down. This is really important if it's a product development project, because a lot of people like to have beta releases, early releases, quick wins where we can start realizing value from the project before the project finishes. So I'm going to say sequential is nearly always better. Now, I do understand the research mindset that you have to keep a few things going in the background just in case they start working out and then you want to switch to them because they're the winners. So what I say is try and do things sequentially as far as possible. Focus 99% of your effort on the one task. And if you need to keep a few things going in the background, then do it at the bare minimum. So keep things going, but without any effort applied to them. Final bit of this is just a bit on general time management. So how to be flexible once you've got a plan, because we know that our project is going to change. We know that we're working in a fuzzy kind of soft project environment. I'm going to talk about a lot more about that in the scope session of this series. So the way that you do that is you define your vision at the top level of the work breakdown structure. So choose that as a sensible level for tracking progress, and only do tracking that you report outwards of the project at that level. And that will be the level that you have milestones on. set a milestone, set a baseline at that level at your kickoff, and then only revisit that baseline at key intervals and milestones, and only really make small changes. Be very careful about making changes to that baseline, because that is your vision. And if you start changing that, then you're really changing what the project is. At the execution level, you choose a sensible task level for day-to-day control, and you work in cycles. So you plan, you execute, you review, you revisit what you're doing, and find a communication format for that execution level that works for the teams. That may be stand-up meetings once a week. It may be something like Slack or Teams where you're communicating online, but it's whatever works for the group of people that are doing the project. Do you have a risk management plan, and do you have a change management plan? That's going to come in the scope management workshop. You can think about other project management strategies. You will hear a lot about waterfall and agile. I'm not going to spend any time on this now. Agile is the buzzword. Be very careful with it. To do agile projects right is to do things in a very particular way, and it doesn't apply to all projects. But some of the concepts within agile are quite nice, so it is nice to learn about. So, quick recap. I've covered tools, PERT, the work breakdown structure, deliverables, critical path analysis, charts and milestones. Remember that a Gantt chart is a picture, it's a communication tool. The information that goes into it is important. Bit about duration estimating and using that. The advantages of sequential work, I hope I've convinced you of that. And then a final bit on schedule management and practical schedule management. So that's part 2. Looking forward to part 3, because we really get to use some of the project management tools out of PMBOK, and really think about how we adapt those for research projects. So it's a really interesting session. So I look forward to seeing you again in part 3.